Guys,
Good morning.
morning, thank you. So we just need to go over the warm-up quickly before we jump into today's business. So for number one, we did very well. Most of us were able to find the vertex, to find the axis of symmetry, as well as to state whether the graph opens up or down. What determines the concavity of the graph? When I say concavity, it's up or down. What determines that?
If the A is negative.
Correct. The sign of A. So when A is positive, what happens to the graph?
It opens up.
It opens up. What about when it's negative?
It closes.
It closes or it opens down. That's good. Okay, so with that being said, we just need to quickly go over this discussion question. How do positive versus negative A values change the shape? We talked about it, right? All right, how do the signs of B and C affect the graph? Remember, it's an equation in standard form where we have A, B, and C. As those are A and B, these are the coefficients of the quadratic term, and the linear term, and C is the independent term. So how do those signs affect graph? The signs of A, the signs of B, and the signs of C. So what I'm saying here,
It's how each.
when A is negative, when A is positive, when B is negative, when B is positive. We want to see when C is positive and C is negative, what happens to the graph?
Well,
Let's start with A. We talked about it, right?
Yeah.
So for A, we said what? When it's negative, it opens
Upward.
down. All right, let me use this one. Okay, let me just use this one. It opens down. When it's positive, it opens up, right? What about B? What does B affect the graph?
Okay.
How does B affect the graph?
It affects the
Does it affect?
zeros.
Does it
The
affect the?
x-axis.
All right, so B value, it affects the graph in the sense that it determines the horizontal movement of the graph, right? So when B is greater, here, we are going to see that the vertex is going to move to this side. So when B is positive, it moves to the left side. You know, if you still remember the transformations, when we add, if it was f of x plus a, we are moving this side. If it's f of x minus a, we're moving that side. So again, when B is positive, the vertex moves to the left. And when B is less than 0, the vertex moves there. So it determines the horizontal placement or the horizontal movement of the graph. What about the C? Yesterday, what did we say about C? C is what? The y-intercept, good. So when the y-intercept is negative, what happened to the position? Is it above or below the x-axis?
It's below.
It's below, good. So here, the y-intercept is below the origin, right? Here, it's above the origin, right? So basically, that's how the signs for A, B, and C affect the graphs, right? So with that being said now, today we want to sketch. Remember, by sketching, we are not plotting. Sketching, we are just showing key points. So today we'll be sketching these quadratic graphs from its standard form. Remember, we are still talking about the standard form. Yesterday, we considered the standard form of the quadratic equation where we were determining the vertex, the axis of symmetry, and the zeros, right? So now, I'm 100% sure that everyone now knows how to find the vertex. How do you find the vertex?
It's like D.
Which
equals-
formula do we use?
It's like D equals negative B over 2A.
So it's x equal to negative b over 2a. This is the axis of symmetry, right?
Mhm.
When we have this value, how then do we get the y value? We plug in that, right? So we are going to plug in this to get the y value. That's good. And obviously, you use the known methods to find the zeros. Let's state these methods. Which methods do we use to find the zeros? No, one. Quadratic formula. What else?
Factoring.
Factoring and
square.
Completing the square. Good. All right. Yesterday you said the same thing. Square, you were not sure about the completing part. No, it's fine. Okay. So now let's go ahead and find the vertex, the axis of symmetry, and as well as the y-intercept and the x-intercept, and we're going to tell whether the graph has a maximum or a minimum. Right. So here we say x equal to negative b over 2a. Right. Genesis, what is the b value here?
4.
B is 4. Right. Asia, what's the a value here?
1.
It's 1. Good. So now it's negative of 4 divided by 2 times 1, which is negative 4 over 2, which is minus 2. So the axis of symmetry is x equal to negative 2. Now that I have this x value, right, let me write it here. So the axis of symmetry is negative 2 because I need the vertex. Remember, the vertex is the coordinate, complete coordinate. So I need both x and y. Let's go ahead and plug this value into the formula. So y is equal to negative 2 squared plus 4 times negative 2. I hope we are seeing how I'm using the parentheses, right? Because if you omit this parenthesis and use the calculator, you're going to get the wrong answer when you square. So here it's now 4 minus 8 plus 3, which is negative 4 plus 3, which is negative 1. So my vertex is negative 2, negative 1, right? Since A is positive, are we going to have a maximum or a minimum?
Minimum.
A minimum, good. Remember, when A is positive, the graph opens up. So when it opens up, it has a minimum value. That's good. So we're going to have a minimum point. So it's going to help you when you actually do the sketching, right? Then what else do we need? We need the x-intercept or the zeros, right? Go ahead, guys. Give me factors of positive 3 that sum to positive 4.
3 and 1.
3 and 1, good. So it's x plus 3, x plus 1 equals 0. So when we solve, x is negative 3 or negative 1. So my intercepts are x equal to negative 3, x equal to negative 1. One last thing, how do we find the y-intercept? Even without calculating it, you can
right
actually
there.
see
It's
it.
the C.
Is the
Correct. The C part, which is what? 3. So my y-intercept here, my y-intercept is 0, 3. Now that we have all the recipe that is needed, let's go ahead and sketch the graph. Remember, like what I said, when sketching graph, guys, you don't need to show all unnecessary points. You just have to show the key points. Right, we are sketching. This is what I want to make sure I use the grid that I've attached on your glasses. Right, so here is our XY plane. Right. Then you are going to see that our x values are negative 3 and negative 1. So I will put my negative 1 here and obviously my negative 3 there. Right? Then we have our vertex. Remember, vertex lies halfway between the two zeros. So it's negative 2 for x and negative 1 for y. So my negative 2 here is here and my negative 1 is somewhere there. Right? Okay? That's where my negative 1 is there. Then from there, you just go ahead and connect. So we are connecting, it's a parabola. So we connect this, right? Then from there, you then have to state your y-intercept. And we are done. So as you can see, we have the x-intercept, we have the vertex, we have the y-intercept. But the question requires us to graph this function. Then we have to label the vertex, the axis of symmetry, then x-intercept, y-intercept, and max and min. So now, you know that's where my vertex is. So you are going to indicate that my vertex is there. This one is one of your z. You can just say x into 0. This is a 0. That's another 0. This is the y-intercept. So you can go ahead and draw your axis of symmetry. So that's my axis of symmetry. Now we are done. We met all the demands of the question.